Excuse me, Professor Calix.
Yes.
May I ask a question real quick?
Yeah, go ahead.
My graded lab, I just saw the feedback and it said that I was missing a screenshot, and I was just wondering if I could ask what screenshot I was missing.
So when I said that you were supposed to have 2 screenshots of the encrypted square and circle with ECB and the encrypted square and circle with CBC. So in one, you can still make out the square and circle. In the other one, it's just, you know, it looks completely random. So unless I did, you know, maybe I didn't see it in your report, but that's, you know, you probably had one of the 2 images, but not both. So that's what I meant by that.
Okay, thank you. I'm gonna double check my report because I believe I had that on there. I just want to make sure though.
Yeah, double check. If I missed it, you know, I'll correct it. But the whole point is that with ECB, you can still see the square and circle. Without ECB, with CBC, you don't. So the point is to understand that one method is way better than the other because it, you know, you can't make out anything of the original plain text. All right, guys. This is 350, ITS 350. Welcome. So today is lab. You guys will submit PKIA, I believe. That should be due today. Let me double check. Yeah, I've created the homework and it's due September 20, yeah, which is today. So that's your homework assignment for today. Then I will remind you, please don't forget that we have exam 1 on Tuesday, please. It's gonna be at this time from 4 to 5:40. It's gonna be our written exam online somehow. So prepare for that. And please don't miss it. All right, so on Tuesday, we started doing RSA, right? So I started covering that topic, which is, you know, hopefully you're enjoying it, very interesting. As I said, this week, we're gonna do PKIB, which is the second part of that PKI lab. However, I'm not going to assign a homework that's due a week from today, given that I want to give you time to study for the exam. So what I'm going to do instead is that today it's just kind of an open lab for you to ask questions, you know, anything that you want to have. You can, however, start working through PKIB if you'd like. And as far as the scripting parts, I will do that with you guys next Thursday. So basically, I'll kind of lay out, you know, the problems. You can see here in, I have a Word document that hopefully you can see. Can you guys see this Word document?
Yeah, the crypto PKI doc.
Yeah. So please don't use the chat. If you're going to send me something about your homework, email it to me. If you have a report or something, please send me an email. All right, so you can see the Word document here. So in this lab, you're going to complete 3.6 and 3.5, and I suggest in that order from the attached PDF crypto lab. So 3.6, you must answer the following: how are integrity and source of the file verified in this problem? And what pillars are used and why? For task 3.5, based on the results from the script, how long does it take to encrypt and decrypt? So this is the problem where we're going to do performance, okay? We're gonna do performance. And so this, I have to give you some little script, so I'll do that as well. And then after that, so most of these we will do next Thursday. So the Bob one. So this is the problem that I did in class, and I'm just going to show you how to do that in Python very simply, just so that we can kind of understand it. Then I should have provided, I'll check in a second, additional script on this thing, Brightspace, and we will go over that as well. So I'll kind of lay out, most of the functions are there, and it's just really kind of using it, but it should give us a little bit more insight into the, the algorithms and how they work. So really what I would recommend, if you'd like, start working on this right now or ask questions. As I said, today is more of an open lab. I want to see if you have any questions about anything, any labs or anything like that. Or otherwise start working on this, which should be 3.6. If we go back to the PDF, should be, where is it? Should be this, I guess. Yeah, should be this one. Yeah, 3.6, which is the last one, should be a digital signature, I believe, using OpenSSL. So you can, yeah, we can do an overview of the exam in a second. So we will do that. Okay. So here is create a digital signature, right? So that would be the problem you can start working on. On this one, pretty much kind of what we've talked about in class, but now you're going to try to implement this in OpenSSL. All right. So that's the idea. And then I've also provided here some of the scripts that we will be using. So I think this one. Yeah, so this should be the script, and I will go over that, but before we get to all of that, let's just go over questions. So are there, so somebody asked me to do a review. Well, I'll kind of go do an overview. And then are there any questions about PKIA at this time? So I graded your 350 homework also, secret key. So look over that. If you have any questions about your grade also, this would be a good time to ask them. Okay. So are there any questions?
I have one question, Professor Calix. So for our lab, do we need to, when we take a screenshot, if we take a screenshot of the entire task and all the instructions and the things that we need to follow through on, and then we take a screenshot of our execution, is a written explanation below the screenshot necessary?
Yes, please provide just 2-3 sentences. Sometimes I'm actually just looking for the conclusion. So for instance, I'll give you an example. In the padding example, or sorry, problem, I was looking for you to say, so obviously these two have padding and these two don't have padding. That was enough. Or you just to say that and show me the screenshot. I know that you understood what you were doing without just throwing screenshots at me. Make sense?
Yes, that makes sense.
Okay, great. Any other questions?
Will the material on the PKI Part A be on the exam too?
The idea is yes. Am I going to ask you to do that lab? No, but the exam will be mostly about understanding everything that we've been doing, right? So how to create the written exam, I mean, will be about understanding how to, asymmetric encryption, symmetric encryption, the keys, when do you use public, private key? You might expect, I might say achieve confidentiality. If you go to a coffee shop and somebody, you open your bank, information and somebody looks over your shoulder, which pillar has been affected, you know, those kinds of questions. Make sense?
Yeah.
Yes, it does. Thank you.
Okay. Are there any questions on the homework? Oh, sorry, on the homework I graded, Secret Key Lab. Please take a few minutes to look at what I either wrote or your grade that I gave you. And if you have any questions, please ask. No questions on the homework?
I don't have any at the very least.
All right. All right. If there's no questions on the homework that I graded, then let's talk a little bit about the exam. So as I said, you know, it is a written exam on Tuesday from 4 to 5:40. It is going to be, you know, everything that we've covered from the beginning of the semester until now. I may ask you explain, you know, what is symmetric encryption, what is asymmetric encryption. It's going to cover everything up until what we covered today. Although today, you know, I don't plan to give that much new material, just really, I wanted to leave it open for questions. If you have any, I always like to do what I guess I call a catch-up lab, and today is kind of that. So catch up if you're behind. And if you're ahead, then just start working on the RSA Lab, start reading through it. The things that are in this lab are not going to be on the exam. So I'm really, I guess, mostly what I covered on Tuesday. You could see problems of RSA like the one I showed you. It'll be very simple though, pretty much how I did it in class. Make sure you understand right now. I know we haven't gotten to all of it because it'll take some time to get through all of it. I do want to, although someone asked a question about PKIA, that if you would have to, I'm not going to ask you to type the commands that you type to configure PKIA per se, but I will ask questions about understanding how the client server architecture works, and in particular, the certificate authority, right? So if you remember, I explained certificate authorities last week, and again this Tuesday. So that's really the main thing there in PKIA, is that it's a certificate authority and how all of that fits in the process. Okay. Are there any questions about the second lab, hash integrity lab? Is there anything you want me to answer for you or address? That one was due last Thursday. Okay, so it doesn't seem like there's any questions on that one. What about on the one that's due tonight, PKIA? So how many of you have already submitted that lab?
I've submitted it.
Yeah, you guys can't see, you're only seeing a black screen right now, correct?
Yes, sir.
Yeah.
Yeah, all right, so I did that because I'm gonna look at the grade book and I don't want that to appear. So I just want to see who has, you can't see the grade book, right? All right, so a lot of you already submitted, I think. That's good, okay, good. So a lot of you have submitted, that's great. Let me get out of here. So it seems that you you have no problems with PKIA. So what did you guys get at the end? So you're supposed to get a screen, right? Remember I said you get to the browser, you want to visit a page, and if you did everything right, it's gonna recognize the certificate, and you see just basically what looks like encryption algorithm statistics. It looks like a whole bunch of encryption information. However, if you get to the page and you get a what do you call it? Something that you see like a watchman there, like a police officer or a traffic cop, I guess, saying, you know, you're going to a bad place. Do you wish to issue an exception, right? If you get that, then you've done it wrong. So even though if you get to that and you click exception, it's going to let you get to the page, but that's not the solution, okay? Because the solution is to actually, if you see that traffic cop, you've actually made a mistake, all right? You should not, or something is not configured properly in your setup. And so the exception is not, exception actually means you didn't do it right, but you're still going to get to it by adding that exception. Instead, it should just get to the page. It should recognize the certificate that you created as a certificate authority, and that's it. So that lab, you know, it's difficult in the sense that it's got a lot of steps that you have to be very careful when you're doing it, but it's not really such a bad thing. And the idea is remember the main goal there is to understand certificate authorities. So are there any questions about PKIA? Okay. Okay, so when you get, so I got a question that says I cannot add 127.0.0.1. Yeah, so somebody answered for you. C to etc host, for some reason it opens as read-only. So you need to use nano, and if, yes, exactly. And it's probably a permissions issue, okay? So what it means is that if you do ls space -l on the terminal, which is a command, and you look at the permissions, it might say that, you know, it's a file that maybe only sudoers can modify. Sudoers, as we will see in ITS 372, when you guys take it next semester, which is the system administration / Linux class, you guys will see that, you know, you'll understand all those commands. So basically you'll be looking at the permissions of the file. And that's probably the reason. So if you, somebody suggested on the chat, if you just type sudo nano the file, then you should be able to modify it, right? The 127, as you probably learned in 170, is just a redirect to the local host. Any other questions, guys? So as I said, today's your lab. Ask questions. I'm not, given that we have an exam next week, I'm trying not to give you too much work. And instead, I want you to focus on studying for the test. Remember, we will also have a practical exam, but that's not yet going to happen. The practical exam usually happens a little bit closer to the second exam. So I'm not sure when, probably around week 11, maybe the same week as the second exam, which would be week 12. But the practical exam has to be really once we've covered everything in cryptography, not at this time, it's a bit too early. Any other questions? All right, seems like there's no questions. All right, so let's do this overview of the exam. So I'll just remind you. So some of the ideas, you know, exam 1. Can you guys see the board, the whiteboard?
Yeah.
Okay, great. All right, so exam 1, right? So you can expect around 10 questions or problems. Now, sometimes a question will be like question 3, but it'll say A, B, C, okay? So there might be, yeah, great, thanks guys. So it might be, you know, question 1, but 1 part A, part B, part C. Sometimes they're independent. Sometimes you need to solve A for B and then A and B for C and so on. All right. I'm not going to do any multiple choice or anything like that. I usually don't do that. Instead, it's going to be more open-ended or essay type problems or questions. As I said, you know, first thing you want to remember is the principles. So we talked about confidentiality, integrity, availability, non-repudiation, authentication. Make sure you understand those really well. And in particular, make sure you understand them in relation to cryptography, right? If I ask you to achieve integrity and authentication, that's all I'm asking for. I'm not asking for confidentiality, right? Or if I ask you, you know, what is a digital signature? You know, you need to use the correct primitives to describe it, okay? So now I usually don't ask for things like what is the OpenSSL command for this? Although you know it's open notes. I mean, I can't control the environment where you're going to be in. You're going to have all your notes there. Don't waste time trying to solve something by Googling it. Just, you know, you're going to waste a lot of time. I can't, again, control that, but I would just suggest, you know, study and then answer the questions. You won't have time, really, to look for things. All right, so, you know, I'll ask questions about the principles, then, you know, maybe I should be using, no, I'm just going to use asterisk. All right, then things that I'm going to use, ask about secret key. All right, and that's symmetric encryption, remember, please. All right, so I might ask some questions about symmetric encryption. I might ask about ECB, CBC, you know, block ciphers. Okay, remember XOR, right? Remember the one-time pad or OTP, you know, by Claude Shannon. Remember the, you know, what makes a cryptographic technique secure. So, you know, also that you need to probably address that in some way. Okay. We talked a little bit about DES and AES. We haven't gotten to the algorithms yet, but we've certainly talked a little bit about it. We talked about padding and initialization vectors, so make sure you understand that. Okay. So that's secret key. So remember, you know, mainly what pillar is addressed by secret key encryption. Okay. Then we talked about integrity, right? In hash functions, we did the XOR hash algorithm. So I went over that. So make sure you understand that one. I could give you a problem where I tell you, you know, calculate a hash number using the XOR hash, and I give you a sequence of bits, right? So that's a possibility. So make sure you remember that. What else? You know, the definition of a hash function. So make sure that's clear in your head. Okay. Then, you know, authentication. Okay. So that takes us to asymmetric encryption. So make sure you address that one, okay? So asymmetric crypto or authentication. We started talking about our RSA, so make sure you go over the algorithm as was discussed on Tuesday. So that main idea. Think about how, you know, obviously we talked about public and private key. Right, so understand the difference, which keys you need to use for what, okay? So we talked about PKI, the public key infrastructure. Public key infrastructure. Okay, so make sure you also understand that this is what PKIA is, this lab, right? All right, so understand the client server use case of encryption. Right, this is HTTPS basically, as you're familiar with it. Also, we covered certificate authorities. Okay, certificate authorities or the CA. So make sure you understand that whole relationship of certificate authorities and the CA. Okay. Also, we talked about digital signatures. And remember that I can play around with those different things, right, to achieve the different principles. So I may do problems like that where I say, okay, use these primitives, but build a system for confidentiality, or use these primitives to build a system for authentication. How do you achieve both authentication and integrity at the same time? You know, those kinds of questions. So we had 3 labs so far: the secret key lab, the hash lab, and PKIA, right? And most of the ideas are going to be based on those questions. Okay. And you know, that's pretty much all we've been doing so far, is just understanding those basic concepts. So as I said, you'll get 10 questions or problems related to this. Okay. Are there any questions?
Not for me, at least.
All right, so it's clear. That's good. Let's see if there's any other questions. All right, no questions. Good. All right, so I see that some of you have submitted the PKIA lab. So then all I'm going to do is, as I said, there's no homework, but I will, if there are no questions about the topics, let's just go to the lab and kind of take a look at, you know, what you can start working on. So let me go to the bright space here. All right, so the current, I guess, the lab that for those of you that have already finished, right? For those of you that have already finished, and if you want to start working on a lab right now, it would be the RSA Lab. So it's basically just a PKI continued, now called PKIB. You're going to find in there a Word document, which is the Word document I showed previously. Follow that document as I showed. Definitely. So, and then don't worry about the Python scripts right now, because I will do those in class next Thursday. I'll just kind of help you out with them. And then, so really, let's read through the first problem. So I'm gonna have to, let me download this. Okay. So I'm going to share the PDF. So you have at this, so you should be seeing the PDF. So at this time, you should have completed, become a certificate authority, CA. Follow all that. You should have completed task 2 and use PKI for websites. So that's everything until, as I said, here, and that's what you're submitting tonight. We're going to skip the 3.4. And then what the problems that you have to do are this one, 3.5, but this, I have to give you some code for this. So I will do that next Thursday after the exam. And then this one you can do on your own, because this is really just doing everything that you've been doing so far, which is using OpenSSL. Okay, so you'll be using OpenSSL to create a digital signature, pretty much as we described in the lecture, right? So in this task, we will use OpenSSL to generate digital signatures. Please prepare a file, example.txt, of any size. Please also prepare an RSA public and private key pair and do the following. And you're going to sign the SHA hash of example.txt and save the output in example SHA-256. And then you're going to verify the digital signature in example SHA-256, right? And then the other thing, as usual, you're going to modify something in the file, either by changing one bit with ghex or just directly in the file. And then you're going to do it again and compare if now the digital signature checks out or it doesn't check out. All right, so so that's all the new content that I'm going to give you for today. So for those of you that are working on, that are done with the PKIA lab, start working on 3.6. All right, try to solve it. And so given that this is an open lab, I'm going to stop recording now, and I'm just going to I'm going to come back. Or actually, no, I don't need to do that. I'm going to pause. That's what I'm going to do. I'm going to pause the video, the recording, because I'm not going to give you any new material today. And instead, I'm just going to stay over and ask any questions that you might have or help you out with your lab. Okay? So I'm going to pause it now. All right, guys, we're going to stop here for today. If you have any additional questions, please email me. Don't forget that your exam is on Tuesday. So please get ready for that. So we'll start the exam on Tuesday at 4 o'clock. All right, thank you. Have a good weekend.
Thank you, you too.